Hello, Manoj.
Yes, visible.
Yeah, sorry for that. I don't know what happened. My team's just closed.
Okay.
Hey, so is the screen visible?
Yes.
Right. Right. So let me Autonomous agent. There we had multi-agent systems. So yeah, here I should explain on the example. Uh, I just get this. So let me start with like our example. Okay. So I'll just
Okay.
explain that example. It's a simple one, so it will be on note, right? So once I explain it, you can put your questions. Okay.
Mm-hmm.
So here in our architecture, we have majorly three parts. So that is a router node or a router agent. Let's say there is a worker agent and there is a critic agent,
Right.
right? So even in our example, what we took, so we put up like exact layouts. So that is we have a router agent. Okay. So this router agent will get the user input. Okay. So user input could be anything. Okay. So it gets this user input and it has to decide between these two agents which one to use. So we call it like worker one agent, worker two agent. This was responsible for joke or creative tasks like storytelling, and this was responsible for to act as a calculator. Right. So we had these
Mhm.
two agents, worker agents, and then we had like a layer of like QA agents, QA agent, okay,
Right.
a single
Correct.
agent.
Yes.
So this will take this user input as one parameter, and the other input would be so whatever. So let's say the creative agent generates something that would be input for QA. If calculator agent generates something that would be input for QA. It will check it against user input and review put up its feedback. Right.
Mm.
If everything goes right and the QA agent is satisfied, the answer will be available for us as the final answer. So unless the satisfaction, so this is final answer. Unless the QA is satisfied, this is not a final answer. So answers generated here are draft answers. Okay. So they could be altered. Okay. Once the QA approves, the pass happens. So then the answer is visible to the user. So that is the final answer. Okay. So this was our system. So this was the example which we built.
Right.
So this router agent, the whole purpose of this router agent was to consider the user input. Okay. To
Mm.
consider the user input and decide between whether it's need to choose between a calculator agent or it needs to choose between a creative agent. So that was the only task that has been given to this router agent. Okay.
Mm-hmm.
What was your question?
Why don't we assign in the beginning itself that use this particular
In the user
logic
input,
or calculator? Yeah.
like I'm a user and I'm using this application. So you want me to write up a user prompt such that so use a creative agent. Okay, use a creative agent you have to
Mm.
generate me a joke on something. Okay, right?
Mm.
So this should be the prompt you are saying, right?
Right.
But why? So if user is always this intelligent, he can use LLMs to do all these tasks, right?
Oh, but since we observe that there is no proper training for LLMs, it might also behave in such a way that it might choose wrong agents and work in such a way that we
Right.
keep.
Yes, makes sense. So your justification makes sense. But we have to understand one thing. There is a fine line between. So this is user. So user doesn't know how this system is developed. And there is developer who has developed this system. Correct?
Mm-hmm.
So all the internal logic, what are the agents available, what are the tasks it can do, that is known by developer, but user doesn't know. Okay. So depending on user request, the router is routing in the available agents. So it is routing within the available agents, right? So let's just say this user comes in and instead of asking for a joke or a storytelling or maybe a calculation, he starts explaining. Let's just say I'm an emotional being. I went through this. So help me with what I should do next. So that is like more of a counselor, right?
Mm,
It's a counseling. So there has to be a counselor agent to actually understand this, and we don't have that in our arsenal. So we don't have this imaginary counselor agent, correct?
right.
So if this prompt comes in, so it can't choose between like either joke or creative, sorry, joke or storytelling, that is creative agent, or it can choose between choose calculator agent. It can choose neither, right?
Okay.
So now, and we don't have other agents here. So we don't have this counselor agent. Okay. So now what we should do is, so what we have prompted to this router query, sorry, router agent is, so if the user task is related to creativity, okay, that is storytelling or joke, answer back with creative word, correct? If the user request is for a calculation, okay, then answer back with calculator, correct?
Yes.
So the router is responding me with only these words, creative or calculator.
Calculated.
Okay, so we have prompted it in that way. Okay, so this is the context we have given. So it
Mm-hmm.
can either choose between this or this. Intelligently, if we are building the system for like enterprise, right? So we should have also included one more statement, that is, if it can't choose between either, respond back with this particular maybe a custom message. Okay, so if that custom message may be something like, let's say, help. So it doesn't understand what to do next, so it is asking for help. And if this help is generated, so we could have written a Python function or a Python code, Python logic, which could, whenever help is generated, it could provide a user with a custom message that this system is not meant to do this task.
Mm,
Correct?
yes.
So ideally, if you are creating such systems in an enterprise, right? So
Mm,
we usually add this particular logic. But since it's a simple example, so what we added was like it can choose between creative or calculator, and in the user input we provided that tell me a joke on like a production issue, engineer solving a production issue. So it could have chosen joke, right? If we ask for some calculation, it would have chosen calculator. So user usually don't know. So if the developer himself is a user, he knows like how to prompt it and how to use the best of the system. But user doesn't know how the system works. So he know he is putting up an input and he know he's getting output. The logic is black box for him, correct?
mm,
Right. So yeah, that's why. So that's why we have a router agent to route the tasks between like different available agents. Right.
okay.
Does that make sense?
Yes.
Okay. But yeah, Llama 3.2 also, although it was a powerful model in the sense like a smaller version of powerful model, but yeah, there could be bias, right? It could make mistake. So it chose calculator. Even I don't know like why it chose calculator. Even when we have prompted particularly that it has to choose creative whenever it is a creative task. We have prompted it properly, but still it chose calculator, and this can happen. That's why the need of QA engineer comes in. Okay.
Mm,
Uh, yeah, quality AI engineer is to ensure that these systems, such like this was not supposed to happen, this happened, and we need to recognize it like when it happens, and we need to recognize it every time a system update comes in, or let's say a new system is generated, we have to check against like golden data. Golden data is like truth data, which we know, against the data that will be generated by the system. Yeah, we will discuss on this. No worries. So as of now, we were discussing on agents and then agentic AI. So this was a simple example of agentic AI. So yeah, I guess Saurabh won't be joining. Yes, only two of us, right? Okay. So yeah, any doubts at this point within this example?
Sorry.
No,
No. It
no
was,
doubts.
I was on mute and I was just talking.
Okay, okay. So you were talking in the sense you were saying yes, or were there
Yeah,
doubts?
no doubts, no doubts.
Okay. So yeah, now let's discuss on like the yesterday's problem. Okay.
Sure.
Yes. You want me to present something like have you created something to present or any such?
No, but I can verbally tell you.
Okay, okay. Just tell me. Okay, and I will try to make sense out of it. And if I don't, please correct me. Okay.
Okay.
Yes.
So, it's about the meeting agenda.
Yes.
So we have three agendas. One is summary, giving the charts, and also description.
Yes. We need
Description of
summary.
the
We need
meeting of 2 hours. Yeah,
XML chart. If it can be generated, if not, that's fine.
yeah.
And what we have, that is process
Description.
description. Correct.
Yes.
So what's been discussed and how it goes, the flow and everything, that is process description. Okay. These are the three elements. Can I call these deliverables?
Yes. Yes.
These are deliverables for us. Okay. What next?
Um, so
Mhm.
so can we create agent individually or route as per the routing
I
we
mean,
need to
we don't.
create?
I mean, it's not specified that we have to use agents, of course. So since we know like AI systems, how it
Mm-hmm.
works. Okay, it may be simple LLM interaction, or it may be RAG, it may be agent or agentic AI. So we know this
Mm-hmm.
now. So
Mm.
try to answer this like using any of this. That's your personal choice. Okay.
Your voice got little disturbed. Can you repeat?
Okay. Yeah. So we have explored these AI systems, right? So
Right.
using any of these AI systems, you can try to solve this problem. No worries. You don't
Oh,
have to use agentic AI itself, but if you want to, yes, you can. So yeah, we have this, let's just say 2 hour transcript. Sorry. Yeah,
two
transcript,
hours
right?
of meeting. Yeah.
Okay. Yeah, meeting transcript. All right. Let me put up some design there. Okay. Next.
And then we create an working agent. Uh,
So we
we
create an agent. Okay.
Yeah, we write code. We write Python code for it to
Okay.
give a summary. Oh, whoever the participants have taken chance in the meeting,
Okay.
uh, the transcription, uh, the transcription of the meeting.
Okay.
It's like summarizing. We write
Mm-hmm.
code and and then it goes to Q&A,
Okay.
whether it has properly done the task or not.
Okay.
And then uh, it can present to the user.
So let me build a wall here instead of like single elements. Yeah, that is the final response.
Final response.
Okay. So yeah, agent one generates the summary, only the summary, right?
Yes, only summary.
And it is passed to QA and it checks the user the transcript against the summary and the final response is generated. Okay. So what about other deliverables? So
Other
do we have
deliverables.
other agents?
So yes. So
Agent
so in the
2.
so for pie chart to create that XML pie charts or whatever,
Mhm.
we'll write the Python code, and wherever the numbers or the data is heard in the transcription, the meeting transcription, it will be displayed in the form of pie chart.
Okay. Pie chart.
I mean that XML mm,
Okay.
a chart.
Diagram. You can say
Yeah,
diagram.
diagrams. Yeah, diagrams.
Okay. Let me just remove this and put a diagram here. Okay, XML diagram. All right. So this agent one, if I explain it agent one, so this contains what it contains. This is an LLM, right? Which is summarizing. Correct.
Right, right.
So so agent two. So this is Python code to generate XML. Am I right?
Yes.
Are you sure on this? Okay. So agent three is
Agent 3 creates
process
a
description.
complete description of the meeting.
So
Um,
yeah, so this is again LLM, is it?
yes,
Okay, so it takes LLM. This is a Python. This is LLM again, right?
yes,
So all the input for all these would be the transcript,
yeah.
correct? The same transcript. Okay. So now this is passed to QA, and QA will verify all these. So you want to verify the Python code or not?
Yes, yes, absolutely, yes.
Okay. So QA will verify if yes, if it has feedback, it will pass back, and ultimately it will curate everything together, and it will create like one jumbo answer, and it will provide, right?
No, individual answer.
Individual answer in the sense like summary,
This is the summary.
XML description, correct?
Yes.
Yes, yes, fine. Okay, so yeah, this explains this better already. So let me just remove this. I mean, to make up space, that's it. Okay, so yeah, I wanted to, I have some questions here. So the first thing is like the problem isn't solved completely, even if it ideally works, right? So let's say the system works. So even then, our main question was like in this 2-hour transcript, we could have n process, correct? So we could have n different processes. So for each process, we want these three deliverables. Did I miss out of it? All
Mm.
right. So for each of these responses, right, there could be n. And for each of these responses, I want summary, I want XML, I want process description. Correct? So let's just say this n is 3. And in this 3-hour transcript, there are 3 processes that's been discussed. Okay. So essentially, I would have a set of 3. Okay. So let's not confuse with 3 deliverables and 3 agendas. So let's just say, uh, so it is like there are two process being discussed. So essentially, finally, we want like 2 sets where in each set we want summary, XML code, process description, summary, XML code, process description of that individual process. Correct? This is
Yes.
process 1. This is process 2. So here we are providing this transcript to agent 1, agent 2, agent 3, so which actually generates summary, XML code, and LLM. Sorry, the response that is a description, process description, right? So this is a single set. So I want to replicate this whole structure back for second process. Hello.
Yes, yes. Yes, Aryan.
So for the process 2, we want me to replicate this whole thing, right?
Yeah.
Okay, let's just say the n is 5. So you want me to replicate this 5 times? That is more of a chaotic engineering, right? Because we don't know the value of n in the first place, right? It could be 1, it could be 2, correct? Or it could be 3 and usually not, but in extreme cases it could be 4 too, correct? So we don't know what's the number of process that's been discussed in every 2-hour transcript, correct?
Okay.
So first we need to understand that, and we need to divide the we need to understand like which process, how many processes there are, and what are those processes, and depending on what are those processes are, we need to create separate deliverables for those processes, correct?
Mm.
So this system is, so it could be worked when let's just say we know that there is only one single process that's been discussed, right? So
Okay.
then we can provide the whole transcript, and this transcript are like input for this agent to agent 1, agent to agent 3, and they have their internal logics, and it will work. The QA will verify, and it will create a answer, final result. Correct. This will work only when we know there is only single process that has been discussed in this 2-hour transcript. But we are not sure here, right? And also, this 2-hour transcript actually creates like let's just do one thing. I will just Google. I have 2-hour transcript. How many tokens can it have? So 15,000 to 20,000 tokens. That is
Mm-hmm.
simple. Simple enough. Yes. So let's take up the smallest number, that is 15. My bad. Yeah, 15,000 tokens. Okay. So usually the context window of any standard model would be 128K tokens. Correct. So we can easily fit this 15,000 tokens into our context, right? Correct.
Mm-hmm.
So ideally, let's just say you have a chat GPT. So you provide this particular all these 15,000 tokens. Okay. Now this would, so the capability of it would be to take 128K tokens. So it is still 15K. It is way too less, right? Maybe 20% of it.
Right.
So now it can consider this and it can generate deliverables out of this. Correct. So it can identify the processes. Correct. So it can identify, let's say there are three processes. It will generate all these three deliverables. Correct.
Right.
So yeah, that's how it is when you are looking at it like for the first time. But when I try to create this, right, so it doesn't like more of a headache for me, because then at this point I heard of something called, so until then, that point I only knew about context window. After this point, I got to know about something called attention window. Okay. So let's just say you have given 128K tokens.
Mm-hmm.
So that is the context window. That is the memory it can hold. But it can only provide attention to the content of very small part. Okay. So this is the LLM. It has been passed with this whole context, right? Then also it can only like it is more like so we have attention span, right? So first 20 minutes the class would be like great, and after like 1 hour it would be like I can't take it anymore,
Yeah.
right? So depending similarly, so these LLM have their attention window, which specify like first 5,000 tokens, or let's say first 2,000 tokens, ideally 2,000 to 3,000 tokens. Okay. So that is the attention window for these LLMs. So it can focus great within that window. If you provide 1,000 tokens, that is great. It will give its attention to like every token, and it can generate answers. For 2,000, yeah, that's great. 3,000, it may struggle, but more than that, it will definitely struggle. It will, what it will do is, so it will summarize the whole thing. Okay. But since ours is a meeting transcript, so summarizing this transcript could be tricky, right? So we could lose important information that could be needed to create process description or XML diagram. Correct.
Yeah.
So we need like every step here. So in order to generate this XML diagram, we need like what's the first step discussed, what's the second step discussed, all this. So we need it in detail. And the process description, like what's the agenda of it, and how it is achieved. So those cross questions would be there. We have to answer this in this. Okay. So we need more details here. And by summarizing, we will get a crisp of like what the meeting was about, but we never know like those important elements which need to be considered later. Correct.
Okay.
Understandable?
Yeah.
Okay. So yeah, I got to know about this attention window and I searched through this like what it is. And then I got to know like only LLMs can give attention to a certain part of the context. What it does with other context is it will summarize this whole thing. Okay. It will keep a summary of it and it will try to respond. So yeah, that's how it works. And because of that, if you pass the transcript as a whole, right? So this agent one is inside, it's an LLM, right? So now it will get like 15,000 tokens. So this is the average and minimum, right? So I took the minimal tokens, 15 to 20,000 it was. So I took 15,000. So it will pass this 15,000 tokens to this and ask it to create a summary. So it is good at creating summaries. Yeah, it will definitely create a great summary. And then this agent 3 LLM, it has to create process description, but it is good at summary, but yeah, it may struggle with process description, right? With the 15,000 tokens. And and also like in the summary summarizing process, it may consider the whole transcript to be a single process. Correct. So it may think like all the discussion are around a same thing. So I can stitch this whole process and create a like a jumbo process, which includes uh, let's just say so this dish includes like a mixed veg pulao or something like that. Okay. Now it has everything.
Yeah.
So again, could be like a chaotic engineering, a naive approach, or what we call brute force approach. But yeah, it would try to generate the responses, but these generated deliverables would be very low quality. First thing, because because of the properties of LLM itself. Okay, because they are not meant to consume such tokens and give attention to like whole thing. Okay. So yeah,
Yeah.
and this is the attention window. This is not market well. So all the models available in the market, they only speak about context window, what the memory it can hold. So, but the attention window is often very small part of it. But yeah, so they race with like all the models race around this particular numbers because the number looks great, right? 128K tokens, 1 million tokens. But yeah,
So,
so
but
that is the
Arya,
gist of like what's
yeah,
okay.
but in terms
Mhm,
of the real world, let's say we are working in some company and
mhm,
when we use Claude or something, some other LLMs, does
mhm.
the tokens does increase, right? The limit of the tokens is increased, right? And
Mhm.
also, uh, this is the case actually with offline LLMs, isn't it?
Not actually.
Okay.
Even with
Because
like
in
mhm.
profession, what we use, the LLMs that we use the LLMs would have a greater capacity and greater limits uh, to to create such
Mhm.
agents, right?
Right.
If let's say I'm really creating an agent just as per the case right now.
Yeah, yeah, please. I'm just preparing something.
Okay. Okay. So what I mean to say is, in the real cases, we can build agents because the token limit and everything would not be the same, and also it may
Okay.
be easy because of highly trained LLMs that we are using in our daily life.
Okay, great. Yes, I can understand the emotion, but let me just throw up a reality, okay?
Mm-hmm.
So
No,
when you open a
because
plot,
I do have this question because I see people using Claude and in the daily discussions, right? So
yes.
so that's where I feel like it can also there could be a limit increase.
Exactly.
for free flow of using and creating new agents and all.
Right. I completely understand this. And I have also previously explained this once, but yeah, often like I know it. So once I explain, like I can remember that I have explained. But for the first time users, that wouldn't be like great importance. So let's understand like how it works. So this is my Claude. Okay. So I have opened this and I have a new chat. So I start interact with it. Okay, hey Claude, and it generates me like some tokens. Okay, and then I ask for certain question. Okay, let's say I'm asking for a code where I want all these deliverables. Okay, something is there. I have this condition, and it will respond me with the whole thing. Okay, now I have iteration. So this goes on like for let's say 3 days. So I guess you know. So let's just say using the same particular chat for 3 days would definitely like increase the chats to be like a lot more, right? It would be huge,
Yeah.
correct? So it would easily consume 128 tokens,
Yes.
right? So it would be like the question is like, sir, you are saying like the context window is 120k 128k tokens. So I'm including like 500k tokens and it is still working good. So how is that possible? Is your question correct?
Yeah.
Okay. So the model's restriction is still 120k tokens. So what it does is, so let's just say this is your interaction, and just a second. My voice is clearly audible, right?
Yes. Yes.
Okay. So let's just say, so 120k tokens. So this is the point where 120k 128k tokens are exhausted. Okay.
Mm-hmm.
So this was supposed to be your context window, and you should have stopped this conversation, but you are continuing it. So
Yes.
what these desktop based models, or let's just say models like ChatGPT or Claude, what they do is, so once you say like, so this is, let's just say 256 tokens, 256k tokens. So
Okay.
here the sum is, this whole thing is 256k tokens now. So you are twice the limit, correct?
Yes.
So twice the original limit. What it does is, so as you slide, right? So as you exhaust 120k, 128k tokens context window. So what it will do is it would summarize this whole chart. Okay.
Okay.
As you go, so it will create a window kind of thing. Okay. So here you exhausted 120k tokens. Okay. Now it can't hold the whole thing as a context. So now what we'll do is the first few messages. Let's just say there are 1k tokens there. So it will remove it from the context, and now it will simply hold 120k tokens still. Okay. So what's removed is this 1k token. So now the context window, the limit was 128k. Now you have 127k, correct? So now you can chat for like one more 1k tokens, and you go one more other k. So here you lose 1k, correct? So this is called like sliding window. Okay. So or we can call it sliding context. So companies like ChatGPT, okay, these interfaces use this because they don't want to present you that. So usually the earlier chats we did are out of relevance. So when we go further, like after this 120k tokens, okay, that would be like 1 day or 2 day later interactions. So we could have like other questions which are more important, and the earlier tokens are relevant now. So removing that from the context is a great choice, right? So they still hold the 120k tokens, but they're not letting you know that these were the tokens that are removed. That's why. So let's just say you chat for 2 days and you come somewhere like 500k tokens and you ask for something which you started your conversation with. Okay. Now
Yeah.
this model will try to answer it, but it would never definitely answer it. Okay. So this is something like you are in Viva and your interviewer or maybe examiner ask for something and you don't know, and you know it, you know that you don't know, but what you will try to present yourself as you know it, but you can't remember it now, correct?
Okay.
I mean the reality. So the same thing this LLM are doing. Understandable? Does that make sense?
Yeah, but people are writing so much of code here with LLMs, so how can it has a limit is my question.
And 120K is token is a whole like lot context window, lot of context window. And so this is one of the techniques where they are saving their context window. Okay. So they are sliding it.
Mm.
So other thing would be, so every 1K tokens, okay, every 1K token you use. So this will summarize this into like, let's say 100 tokens, 100 tokens. Okay, this could be another strategy, right? So every 1,000 you use, so it will like consolidate everything that you discussed there into 100 tokens, and it will save this as the context instead of the whole 1K, because every detail is not important, right? So it needs context in summary to answer the next question. It doesn't need every detail. Correct.
Mm.
So next 1,000 questions. So 1,000K, it could be like next 100 tokens for it. Okay, it is summarizing it. So in order to save its memory, okay, everything has a cost. Correct. So when
Yeah,
you are
yeah,
online, so they
yeah.
have to keep the track of all this. So they can't use their precious hardware to serve a free tier user the whole time. Correct.
Mm.
So what they will do is, so they give us the hallucination that they are carrying us, but internally they are just summarizing the whole thing so that the bot can answer clearly, but not like all the details are not stored. Okay.
Mm. Okay.
So yeah, 128K tokens now the context window. Even if we have chatted this, right? We have texted this. So if we reduce it as a summary, so what it would be 12.8K token. So where is the comparison? Correct. So you have
Mm.
summary of 12.8K. And usually if you exhaust this much, right? So the chatbot itself will start like responding not too well. And like whenever it does, so you create a new chat. Correct.
Yeah.
New chat is a new session. It
Mm.
doesn't have to remember anything from here, right?
Right.
That's how they actually provide you the hallucination that you can chat for like long, but yeah, they are saving their precious memory.
Yeah.
Understandable?
Yeah.
So this went more like a reality check session. Yeah, I don't have to delete this. Fine, no worries. Okay, any other doubts?
Mm. No.
I guess we can't explore much on what I wanted to discuss
Okay.
today. So it's already 9:50.
Yeah.
I mean, from our end. What's the timing there?
It's 11:20
Okay, it's
morning.
11:20 already. So 11:30 is the end of the session, right?
Yes.
So yeah, we can take this up later. Let's hear like what sort of thought are to solve this. And since you know more on like what to look into, maybe you can definitely critique Saurabh's idea. Okay.
Yeah, but what is the smartest way of doing this? This your use case, your case.
I will definitely explain on that, but not today.
Yeah.
Okay.
Okay.
No, we will definitely solve that problem. Okay, but not today. We
Mm.
should have ideally solved it, but yeah, things went, and no worries, no issues.
Yeah.
We have our time.
Yes. Yes. Even I wanted to explore from my side too.
Sure, sure. Definitely. Since you know like where to look into now, so you can explore better. Okay. So
Yeah.
the same thing I want to explain the first day I did, right?
Yes.
So
Yes.
the same LLM.
Yeah.
It may be Claude, it may be ChatGPT. Even the 5-year-old is using it, and a PhD scholar is also using it.
Correct.
Okay. So how to respond to whom? It is deciding it based on how you provide how you provide the query and how you discuss with it. Correct. It
Mm-hmm.
is trained to please its user with all the knowledge it has got. So it can please 5-year-old by saying rhyme, joke, by appreciating him, etc. But the PhD scholar would prompt something like this. Usually I prompt it my way. Okay. So whenever I create a new chat, uh, So I usually prompt it like, be brutally honest, uh, don't appreciate or don't blabber. All these pointers I provided at the first chat, and then I will start with my discussion. So I usually get those quality discussions.
So
Okay.
people get recruited to train these LLMs,
Oh yeah,
right?
they do. So yeah, they do.
Like how many years? I mean, do you have any idea since how many years the working on LLMs have been started? Maybe a decade?
Okay.
No, just
So this
wanted to curious to know.
okay. So we had machine learning
Okay.
from 1970s. It started. So it still exists. Okay. There
Yes.
are places where we can't fit large processing models. So there machine learning still works great, and machine learning still is relevant whenever we have a defined data set. Okay, structured inputs and structured outputs, and you have to, now you have to predict the next one. They are still relevant in that case.
Mm-hmm.
Uh, Not DDL, sorry. I made a mistake there. Yeah. So deep learning models. So these are relevant when there is huge data. So here you need to like know columns. Okay. So these are set of columns you want to focus on. Let's say weather prediction. So when so the time, the year, or the phenomenon that's happening. Let's say weather direction, or could be like region, right? So there could be multiple things, and depending on that, there is a weather description, and we have recorded for like 2 years or 3 years in a place, and we provide it to machine learning, and it is trained now. So if you provide the similar data here, so now it will predict what's the weather is. Simple as that. Okay, for all these applications, ML was used and still relevant. So deep learning is more of like you have used data, you don't know what to focus on.
Mm-hmm.
Okay, even machine learning does the same, but deep learning does it like way better. You don't know what to focus on. There are some results, so you provide it. This is like huge data. Let's just say 10 years of data you have covered. So you provide it to a deep learning model. It will train itself. It will understand all the statistical patterns that are available within this parameter, within these columns, and now it will respond. So this was the age of like 1990, I guess. Okay, or plus.
Okay.
So these LLM are way new thing. Okay, it was somewhere 2000. If I remember correctly, I'm not sure it's 2016 or 18. Okay, so
Okay.
there was a paper from Google which was published, a research paper, which from was from Google, which was on transformer models. Sorry, transformer, not models, architectures. So we know transformer movies, but not this architecture.
Mm-hmm.
So this was introduced by Google, and this was the base. This was the baseline for large language models. So with the introduction of these architecture, right, we could train these deep learning models on huge set of data, okay, and make it generalize.
Mm-hmm.
So they trained on like whole internet. They provided the internet's data, and then they trained this model, and this model, the name large language model, because we have to understand one thing. Language model, we call it when it understand and respond back. It can respond back with language. Okay.
Correct.
You ask, you say
Yep.
hi, all the Alexa,
Yes,
Gemini.
yes.
So not Gemini. Or what's it? Yeah, we have few.
We have Siri.
Right. We have Siri. Right. So all these Google Assistant, right? So all these were language models.
Right.
Okay. They were connected to internet and they were language models. So they understood the language. They can process the language. They can respond back in like with that language. Okay. So this large language model is like this large comes in because of the sheer size of those models. They are trained on whole internet now. Even in offline, if they are trained once, even in offline, our local models, right? So if you ask a generic question to it, it will answer easily, right? Because
Mm-hmm.
it is trained on that data. So these large language models are not like it is more of a Gen Z tool. Okay, so it grew up with Gen Zs.
Right.
It has not got like lot of history, but yeah, it is making so many histories now.
Hmm.
Yeah. So that was the gist of it.
Yeah.
So anything else? So can I can mention this particular session to be like utility session,
Yes, absolutely.
right? Where we went off with our flow
I'm far
and
more
discussed
interested
on.
in this kind of discussions because that's where, since we don't have any knowledge about this particular learnings, we will get explored new
More
things
understanding
and
on like
more
what the thing we are
understanding.
discussing.
Yeah.
So we read all the theories, we
Unless
understand that
we
particular
explain it,
concept.
yeah. Unless we explain it from our side, we can correct it and we keep it in mind for longer period.
Correct. No worries. So I guess I delivered it as expected. If not, sorry.
Yeah. No.
Okay. So anything else?
That's it.
Okay. Okay. Great. So yeah, we will be okay. Fine. That is good actually. So from Monday, I can explain this. We can solve this particular problem and can create this whole system and also check on like where the role of quality engineer comes in that system, right?
Yes.
So building a small thing and checking it against some data set, right? So that is not the actual QA job that's available now for a let's say quality AI engineers.
Mm.
So the actual job they are into is so how to check through the complex systems. Yeah, of course, there are small systems and we need to check those too. But yeah, the real money is where the complex systems are built and we need to check those. Correct.
Yeah.
Okay. So yeah, we will build this once and at least theoretically,
Sure.
we can take it as a capstone project if you guys want to.
No, yeah, absolutely. Yeah.
Good. And then we will understand like what are the things we need to check into these systems. Fine.
Oh, sure.
Great then. We can
Thank
end the
you.
session
Happy
now.
weekend. Yeah.
Yeah, you too.